You know, have you ever really stopped to think about why a lemon makes you pucker while soap feels so slick on your skin? It's not just random, right? Turns out these are clues, big clues, to this hidden chemical battle going on all around us. So today, we're going to uncover what's really behind that sour, bitter, or slippery feeling. Yeah, it really all boils down to this simple question. We all know that feeling, right? You bite into a lemon and boom, that super sharp, sour taste hits you. And, well, hopefully you haven't done this recently, but if you've ever gotten soap in your mouth, you know it's just bitter. And on your hands, it's got that unmistakable slippery feel. These sensations are worlds apart, and that's no accident. They're actually pointing us to a really fundamental divide in chemistry. So think about it. On one side, you've got your lemon juice, your vinegar. They all share that classic sour punch. But on the other side, you've got stuff like baking soda or soap, things that are bitter and feel kind of slick. They are, and this is the key, chemical opposites. And get this, we're about to prove it with a super simple tool. All right, so how do we actually see this invisible difference? You might think you need a fancy lab, but nope. All we need is a clever little piece of paper that's going to act like our own chemical detective. And that secret weapon is litmus paper. It's basically just a special paper that's been treated with these natural dyes. And what's cool is that these dyes react to those chemical opposites we were talking about. They change color, giving us a really clear, instant answer about what something really is, chemically speaking. Okay, now here is the one rule you have to remember. It's so simple, it's beautiful. An acid, it's always going to turn litmus paper red. And a base, well, it does the exact opposite. It turns red litmus paper blue. That's it. It's like we're watching a chemical conversation happen in real time. And actually doing the test couldn't be easier. It's literally just 4 steps. You grab your solution, whatever you're testing, you dip the litmus paper in for, say, 10 seconds, then you just watch, see if the color changes. And based on that change, or if there's no change, you can instantly know what you're dealing with. It's like the whole scientific method, but shrunk down to a few seconds. But you know, a color change is just the clue on the surface. What's really going on? Like, what's happening at the molecular level to make that paper change color? To get that, we've got to go a little deeper and uncover the chemical secret. So for an acid, its whole identity comes down to one tiny but super powerful particle. When something acidic, like the citric acid in a lemon, gets dissolved in water, it lets go of these positively charged hydrogen ions. We just write them as H+. And these little guys, they are the reason for everything we call acidic, including that sour taste we all know. Okay, let's take a look at a classic example, hydrochloric acid, or HCl. When this stuff hits water, the molecule literally just splits in two. And as you can see right here, it releases a hydrogen ion, that H+. That right there is the chemical signature, the calling card, of every single acid out there. All right, so that's one side of the coin. What about the other, the base? Well, a base is the total chemical opposite. When it dissolves in water, it doesn't release hydrogen ions. It releases hydroxide ions, which are negatively charged, and we write them as OH-. These are the ions that give us that bitter taste and that super slippery feel you get from soap. And here's what that looks like for a base. Take sodium hydroxide, or NaOH. It's a really common one. Just like the acid, it splits apart in water. It lets go of a sodium ion, and more importantly, it releases that key hydroxide ion, the OH-. So, see, it's actually pretty simple. Acids give off H+, and bases give off OH-. Okay, so let's pull this out of the world of molecules and diagrams and bring it right back into our everyday lives. Because the truth is, you are surrounded by acids and bases constantly. And now with this little litmus test, you can actually go find them. This chart just lays it all out so clearly. Check out that first row. You test lemon juice, the blue paper turns red. Boom, it's acidic. Now look down at baking soda or detergent. The red paper turns blue, which tells us they're basic. But here's the interesting one. What about just plain old water? Look, no change at all. And why is that? Because water is neutral. It's the perfect balance right in the middle. Okay, so we've got these two chemical opposites, right? Defined by their H+ and OH- ions. So what do you think happens when you actually mix them together? It's not just a simple mix. What you get is a really powerful and fundamental chemical reaction. The moment an acid and a base come together, they don't just hang out. They react, like instantly. The H plus ions from the acid are basically magnets for the OH minus ions from the base. They find each other, they combine, and they completely cancel each other out. And this whole process has a name: neutralization. So here's the play-by-play. You take a strong acid, like our friend HCl, and you mix it with a strong base, like NaOH. The H plus from the acid grabs the OH minus from the base. What's H plus OH? It's H2O, which of course is just water. And what's left behind? The other parts of the original molecules, the sodium and the chloride. They're just kind of left floating around. So what happens to those leftover ions? Well, as you can see here, the sodium and the chloride link up. And what do they create? NaCl, sodium chloride. You probably know it a little better as table salt. So the final solution is now totally neutral. The powerful acid and the powerful base have completely disappeared, and all you're left with is salt and water. So there you have it. From a sour lemon all the way to the salt on your kitchen table, this invisible dance between acids and bases is going on all around us, all the time. A simple little color test can unlock this entire hidden world. And that kind of leaves you wondering, right? What other simple tests are out there that could reveal all the other amazing chemistry that's just hiding in plain sight?